Welcome everybody to Robot Builders Night Virtual for April 29th. As usual, we're going to talk about robot related stuff. And we're going to go around the table, see whoever has something to present. And after that, we'll go to open mic. Just a reminder that we do record the meetings. So if you don't want to be seen or heard, keep your camera off and your microphone muted. Aside from that, upcoming May 24th, we have Roboama with several different competitions going on, line following, 6-scan, quick trip, etc. Contest is going to be held at, I believe, at the Dallas Makerspace and at the Espanola Recreational Complex in Ontario, Canada. So that's about it. We have a very short list of presenters so far tonight. So if anyone wants to join in after Karim has done his presentation, you're free to do so. Take it away, Karim.
Oh, presentation is a strong word.
Did we just lose Karim?
Hello?
Hey.
Okay, there you are.
Okay. Why my camera no work?
Okay, have we lost his voice now?
No, it's just me being quiet because my camera died. Why my camera die?
Did you tell it go to look at a different camera maybe or something? I assume you were going to present live video.
Something is probably picking it up.
There it is.
Oh, there we go.
Ah, there we go. Okay. So on the Discord I mentioned another LiDAR that I was looking at. Oh, you can actually see.
Yeah, it's coming through.
You can sort of see it coming through.
That's cool.
Yeah, right there.
Yep.
Okay, so this is the unit. It's kind of a chonky little boy. So it's actually on right now in 2D mode. And I'll show you shortly what that looks like. But this has two different motors inside of it. So right now in 2D mode, it's actually scanning vertically over this section right here. You can mount this any way you want. So you could mount it, facing forward or, this is actually the unit that I think is, that ships with the Unitree's quadrupeds. And there it's normally facing down to image the ground to find where its next footfalls should land. It's on a quadruped, it should be sort of somewhat capable of handling vibration and bouncing and such, but I haven't tested it. This is like right out of the box. In fact, I have an unboxing video that I just recorded, but I'll have to go look at it. If anybody wants to see the unboxing, I can share that as well. But this is the unit itself. So I'm gonna put it down real quick, and then I'm gonna share. Let's see if I can share the screen of. Oh, I got too many things open. See if I can find it. There it is. Okay, so this is the camera running right now in 2D mode. And what you're seeing right here is this axis right here is the location of the camera sitting on my desk. And this is, I'm basically in my house. So this section back here is the kitchen. And I'm in the main living room. And so that's pretty much what it looks like. So this is the camera. This is the app that you'll first want to play around with. It lets you do settings like configuring the device, as well as sort of previewing it, get an idea of what the different settings do. It's not really a terribly useful application, and it's kind of flaky in how it works, but like you can't actually do anything with the point cloud that you have here. But I'm gonna go switch over to this work mode tab, and I'm gonna put it in, see it's in 2D mode, but it doesn't know that. So I'm gonna put it in 3D mode, and let's see if the set mode works. I may have to restart the application and share it again, because it does get sort of lost when you switch modes a lot. Let's try to restart. It's spinning. Can you still see the, yeah, you can see that it's spinning up. It sometimes takes a good 15 seconds for it to fully spin up. That seems to be like it's doing a number of different things. It's changing the speeds of the motors slowly. It's warming up the sensor. Apparently the laser has to be a certain temperature or something like that. And that's funky, but that is not 3D mode. That is a spinning 2D mode. Aha. That's now it's going, it goes a lot faster in 3D mode, the main spinning of the unit. But now it's stalled. Has it? Oh, there we go. All right, so this is the room I'm in. Just to give you a sense of its size, this is about a 20-foot square room from the top. Oh, that's another great feature of this application. If you drag the mouse off while you're rotating, it will crash and it won't come back. So I've got to stop it and restart it. Again, this is not the primary mode that you would be using it in. This is just the configuration and verification app. Let's see, I probably have to share it again. Okay. It starts out wanting to be in UDP mode, so this camera has a Ethernet connection, and you can connect to it that way, or you can connect to it through the serial port. Open. Okay. So in here is my messy desk. I think this is me, this section over here. Let me put my arm out. Yeah. There's my arm along here. And this is the camera overhead, this little cloud. I think that's the cord coming off of the camera. You're normally not going to be zoomed in this close, right? Because the range on this thing is supposed to be up to 30 meters. And again, this room that I'm in, that ceiling is almost 30 feet tall. It's able to sort of scan the entire area, but you can see it's a pretty sparse point cloud. You can play with, like, go up to work mode. This first point cloud count is actually the decay time, like how long you keep the points around for. So if I go to 4 seconds, you'll see it fill in. So you get a better idea, but of course, in a high motion scene, that won't be terribly helpful.
Wow.
But there's a lot of data. So if you're like in RAWs or something like that, and you're trying to do mapping, it can, as long as your localization is good while you're driving around, it can register all those points, and you can get a pretty detailed map showing up over time. But again, this is just the Windows application for just testing it. It has a built-in IMU, so if you let's see, it is enabled. I'll disable it and enable it. So no, didn't work. Nope. So this is another thing I wanted to show you. If you look at the camera, I'm going to go ahead and pick it up. And in this 3D mode, it's spinning pretty rapidly, and it wants to shake. So I'm going to sort of just sit it. Oh, there we go. I'm just sort of sitting it on my hand, and you can see that it's shaking my hand around. And it does really weird stuff to display, especially when you've got that long delay on there. But you can see it shuddering around. So this is about a half a pound unit. So I would not recommend it in this mode for a small robot. Don't think it's terribly useful for that. But anyhow, it looks interesting. There's a lot of things that I still need to try out. So I'm not getting my, maybe I have to hit set mode. Oh, trying to get this IMU to start. Maybe I have to restart it. This button that says normal is actually how you put it in standby mode. In standby mode, I think it goes down to about like 1 watt. But otherwise, it can draw a pretty good current. It's a 12-volt power supply, and it can draw like 13 watts continuous. So again, probably not great for a really small robot. So I just hasn't started up again yet. Anyhow, this is the one that is I got one of the last ones off of Amazon, pre-tariff pricing, and for about $419. And I have no idea if it's worth twice as much to somebody. But I don't even know if it's worth the $419 until I get it fully up and running on RAWs and see how it goes. 4 left in stock at Amazon.
At what price now? Or do they say?
I think he means at the $419, because at Amazon they tend to like price it as it comes in. Mm-hmm. So it's only when the next batch comes in that they might. They might even have put it on hold. Who knows? I have no idea what's going to happen.
Like UniLidar themselves are selling it for $419 as well.
Yeah, but if you actually, this is actually the Amazon Unitree store, but if they're out of stock, who knows what's going to happen?
Yeah.
So that's like the price that's been advertised forever, but I've already seen it elsewhere for $800. Like if you go to AliExpress, you'll see multiple prices for these things. Different sellers have sort of updated their prices as they go. So nobody knows how's it going to go.
One question I have is, when you say you had it in your hand, it vibrated. Was it because your hand moved?
Could you see my hand?
Yeah.
You see my fingers sort of flopping around?
Yeah.
So yeah, that's just a byproduct. So here's the unit, right?
In other words, if you put it on like something like
Maybe
our
you can
RC
hear
car,
it.
would it vibrate that much? In other words,
So yeah, that's what I'm saying. It's like right now I'm holding it, and in order to like, I can't completely hold it still, just in my fingers like that.
so it's not
Now,
well balanced.
when it's on it's not well balanced, and I think it's I don't know if it's it's not well balanced. I think it may be a combination of the fact that they got two different motors in there going in two different directions. There's I wonder if I can show this. That application is not working. So, but I'm gonna I will show.
So in their design, they should have balanced it better, and they probably didn't think about that fact. Because, as you say, it's probably geared for a bigger item to sit on. So yeah, that would make sense.
So this animation is, don't share your entire, ignore. Okay. This animation is just showing the laser path in a cutaway. But so this entire base is rotating around, and then this assembly right here is rotating around this axis, this horizontal axis. So it's a combination of the two. So apparently the laser is rotating around with the whole thing as well. The main body of rotation.
Looking at their cutaway drawing there, you can see where. Yeah,
and this is going fast. This is that doesn't look like they could have balanced it. I don't see any weights in there to really balance it well. And this is going at 612 hertz.
Right, but they could have added some rate here and there, but they, at least in this,
they might have. Yeah, I mean, it's not horrible. When I put it on a solid surface, and they actually tell you to use this mat that they send you, because it's like a rubberized grip mat, and when I put it on there, it gets quieter again, and it stops shaking. So as long as it has a solid mount, it seems to be all right. But I wouldn't hand hold it. I wouldn't.
Well, that's why I was curious about robot wheels. How firm of wheels would they need to be?
Yeah, I wouldn't put it on a robot that's like lighter than 10 pounds, probably. I mean, I don't know. I haven't used it mobile yet, but right now it's sitting on a really solid, it's like a 300-pound table, and there are even sections of the table where I can find sort of a resonant patch. Like I had my coffee cup on the table earlier. At a certain location, I could feel vibrations coming from it when this thing is going at full speed. But so I'll see it. My larger robots are kind of chunky, and they're over 20 pounds. So I imagine it's going to be fine on those. But I want to see what it's like at running outdoors. It's supposed to be able to survive up to 100K lux. So 100,000 lux is as bright as it gets in Texas, pretty much. And it says it can do up to 30 meters on like a 90% reflective surface. So and 10% reflective is down to like 15 meters. But if it can do that in daylight, then I'm okay with it, driving up and down my driveway and using that for outdoor obstacle detection. So
don't stick it on a quadcopter. Huh? Got it.
I wouldn't do this on a quadcopter. Yeah, probably not. Although there's an interesting, when I put it, when I get it on the robot on RAWs, there is a Point Leo library. It's called Point Leo. There's a fast Leo, and then so there's a whole sort of history of related repos using some pretty interesting optimization techniques. But so they had a solid state LiveVox on a drone using Point Leo. And Point Leo is a little bit different in that it doesn't like take an entire frame of points and then operate on that. It actually streams them as they come in and does computations on it. And apparently it's got optimizations to handle, completely saturated IMUs as well. So they showed like a drone flipping at, just instantaneous, loop-de-loops and flipping over and things like that, and it was not losing track. But again, that was a solid-state LiDAR on a bigger drone. This thing being a mechanical scanning LiDAR, I don't think it could handle those kinds of G-forces. So it should be interesting to see how that package performs. Anyhow, that's all I wanted to share. I just want to give my first impressions of it.
That's pretty cool, Karim.
Yeah. Do you have an intended use for it? Are you going to use it on do you have a bot in mind for it?
Yeah. So, do I have I don't have a picture of it. Can pull up a web page real quick.
Thought maybe you'd use it on your backhoe you did last year.
Yeah. No, that's not the one I'm going to be using it on. Oh, I got it here somewhere. Oh, let me just better do it from this one. Finally, okay. So this is the robot that I'm putting it on. So this is the P3AT chassis that I have. I've got a Waveshare row arm on there. I've got a GPS mast, and I've got a RealSense camera as well. And so that one does point clouds already. I'll probably do a share on this pretty soon. But I'm basically thinking of putting it right down here or here, and sort of canting it forward, because another thing that it does is like
So I can only see the top of that picture.
Oh, sorry.
You need to click
that's
you're
interesting.
okay in that.
We're only seeing the mast, the GPS mast on the robot.
Do you have a portrait window? Is that what it is? Monitor?
Yeah, it's portrait.
Ah.
Sorry about that. And it's not, the display's not scrolling when I scroll it. That's weird.
Well, right now I'm seeing
Share
something
this
platform.
Yeah, I see the mask.
Maybe
Yeah,
change
there it is.
better.
you go. Yeah,
That's
that's
better.
it.
Oh, yeah. I remember that.
Okay.
So
All
it's
right.
on your Pioneer robot.
Yeah, this is my Pioneer P3AT. So again, this is the arm that's on it. This mast back here is the GPS antenna. And probably down here on either side is where I'm going to try fitting this thing. So it's set for indoor, outdoor. This unit is again they put it on their quadrupeds and they show it like stumbling around on hillsides and crashing into the dirt and stuff like that. But it's actually like a what's it called? The IP54. Is that what it's called? The environmental rating on it. It basically means that it can survive some directional water hitting it, perhaps, but and some dust ingress, but it's not really designed for that. But it's got a pretty good operating temperature range. It's like it does -10 Celsius to up to 50 Celsius.
Wow.
And then the components inside can go up to like 80 C before they stop working, before they shut down. So for Texas, that might be survivable.
Great.
Yeah.
So are those right under the black platform? Those are those sensors? Those
Down here?
Yeah, down right there.
Yeah, those are ultrasonics.
Okay.
Those are the kind that David Anderson likes, and they're just part of that platform. They give a very narrow field of view, like 3 degrees, compared to most ultrasonics might be 15 or whatever, and they can see things like chain link fence. So yeah, again, I'm just using them as virtual bumpers.
Right.
Anyhow, that's the platform that I'm going to put this on. And again, you can tell. I don't know if you can tell, but it's a good sized robot, so it's not going to have problems carrying this thing around.
That's very cool.
Excellent. Thanks for sharing, Karim.
Sure.
Any questions? Tom, if you're ready, you had a short video to show. You're muted as well.
It's there somewhere.
Somewhere there, unmuted.
There you go.
And just a real quick update on the stuff I've been doing. I had mentioned earlier that I had been working on developing a simple stepper motor based robot chassis, so I would have something with more precision than the open loop gear motors I was playing with, which I'm not real happy with. So this simply shows the thing configured. I don't think I showed this diagram a week ago. Voltage regulator panel. This is a 3.3 volt Arduino, which is running the motor driver control software called Stepper XL. Very, very nice library. The intent is that this Arduino will only run the motors for this particular implementation, and it'll receive some speed reference signals from a higher level controller, which I'll show you in a moment. But just to demonstrate this thing works on some very simple software. The intent being the XL decel is working, both motors are driving in sync. It'll go in a straight line. So I was quite happy with that stage of being able to demonstrate stuff. Let me close this. And the level it's at now, as of this evening, simply see if that will show up. So there's a Raspberry Pi Pico sitting on top. At the moment, all I'm attempting to do, since this is to be a line tracker, is to play around with those 3 basic IR sensors that are tucked under the front of this chassis. I'm reading them in an analog sense with the Raspberry Pi Pico analog inputs. Having some problems with those inputs. I don't know why yet, but we'll see. The Raspberry Pi Pico will be interfaced over I2C to the motor driver board, which will operate as a slave. I've done that before, so hopefully that will work again with this implementation. And that should produce a very basic and somewhat improved version of a line follower. I still have my version 1 I can fall back to, which will follow lines as long as they don't curve very much. So I do have a fallback plan if I need to, but I'm hoping for better control with this one. That's it.
Well, thanks, Tom. Excellent. That's a gold star for having a robot rolling.
Yes.
So, significant progress. It's moving well, straight. Good job. Up next, we have no one. I don't know if
Shortest night ever.
Well, I have
shortest night.
something I can show. I think I found if y'all want to digest it. Well, let me share the screen. Once I find the proper button. Present now. And I want that one. Share. So there's, I assume you see this. I found this on Struttables. So there's a 16299 project, and basically they're using a F110 platform with the open source project. So I can sort of read through it. I just saw this, so I haven't really gone through it too much, but looks like it's pretty good description for people if they want to run that. And they seem to use Docker in it. So whoever loves math, there's a lot of it there.
Wow.
So yes. And it's an RRT algorithm. So and it used the ROS2. So yeah, if anybody's interested in any of that stuff, here's something y'all can, as I said, digest. Because yeah, it is lots and lots of info. I'll just run it down to the bottom part because you can see the code's pretty long. Yeah, there we go. So it talks about waypoints. Well, there's that code. And then it talks about how to run it and then building up the car and that. And it's on that website. So it does use a radar and stuff like that. And creating the map. And then running the car. So then they're showing the car there. So yeah, if y'all are into that, there's that website that might have info.
Mark put it in the chat.
Okay, good.
Yeah.
Yeah, I
Gotcha.
just sort of glanced through it, but yeah, looks like they have a decent amount of info in there. So that's what I found so far.
Well, thanks, John. That was interesting.
I got a little something here that you might find interesting. John's through.
Yep. There you are.
Just to call this up for you. I ran across this in the news earlier this week. It seems a couple of years ago, an engineer working in the aerospace field who lived in central BC lost his home to wildfires along with the entire neighborhood. And one of the surprises that he discovered when he lost when the neighborhood burned down was that there was no aerial support for firefighting. And apparently aerial support for firefighting is a very iffy proposition. They don't fly at night. They don't fly in bad weather. They don't fly if there's too much smoke. And yet it's one of the most effective ways in mountainous territories in order to deal with firefighters, with wildfires. So he decided that he would do something using his expertise in automated drone fields. So he got together with some funding and some technology skills, and has been working on developing heavy lift drones as autonomous wildfire fighting aerial systems. He's equipped them with swarm software so he can run them in clusters. These particular drones he's using, they're shown tested here in an area north of Vancouver. He's got a couple of them in the air in this test. The drones look like that. They're quite large. They're about 12 feet square. They have a lift capacity of 400 kilograms each. And he says 3 of them are the equivalent of a standard helicopter water dropping system. So he wants to run them in swarms, and he wants to run them autonomously. He's equipping them with sensors so they can spot hotspots and water and simply turn them loose in a defined area and say, go find a fire and put it out. They're making good progress, apparently, and expect to have them in operation in British Columbia in a couple of years.
I wonder how long those will stay in the air before they have to recharge.
2 hours.
2 hours. Wow.
They're gasoline powered. Eh?
Oh, okay. Okay. Gasoline.
So right now, the standard units, which they buy in Europe, are 2 hours. That doesn't mean they're restricted to that if they're willing to trade off some weight.
So is this scaled to the size of those people there? Is that the size of it?
Yes.
It's not a small thing, is it?
It's about 12 feet square.
I hope it's smart enough to not chop down things that shouldn't chop down and stuff like that. I'm thinking, yeah.
Water is super heavy, so I'm impressed.
They have
that's electrically powered. Those are battery powered.
They're gasoline.
They're
gas powered,
generated. It's probably like those hybrid cars where you use a gasoline motor to run an electric motor. So, it's
400 kilos. It could probably carry 3 or 4 people.
Oh yeah, easily. 400 kilos is almost 1,000 pounds lift capacity each. They're really big.
That's incredible.
So
400 liters of water. That's a good load.
So it'll be run by a person, or is it totally controlled by a computer?
The intent is to make them completely autonomous and swarmable, so they don't interfere with each other.
So hopefully you won't take out your barbecue in the backyard as you're cooking or something like that. I'm thinking.
Kind of reading between the lines, they intend to define a working space, which is typical for helicopter firefighting. Basically when you tell firefighters or aircraft to work in a certain area, you tell everybody else to stay away. The same rules would apply here.
Yes.
Well, I guess an emergency is in a future world. I mean, you could take water in and bring people out. That'd be pretty good.
Yeah. Fascinating application of autonomous drone.
That's really cool. Can you share the link, Tom?
Yeah, I will.
That's cool.
I have something to share when
you're up next, Michael.
Okay.
When Tom is done, you're up.
All righty.
Here's the link.
Thanks.
Okay.
I just wanted to show this. I think his name was Saturday. I sent by David. Did I send by David? I forget it. He's an older gentleman. At the at the meeting Saturday. But anyway, I think Paul also used it. But anyway, he introduced me to this board. This is Waveware. It's a ESP32. Has anybody seen that?
Oh yeah, the general driver for robots.
Yeah.
I got one on the robot that I showed earlier.
Oh, really? What?
Just driving the arm.
You like it?
Yeah, it's good.
Yeah.
Good unit. Paul's
Well,
using it too.
That's a new toy, so that's all I got to share. But he impressed me enough that I bought one right when he was talking to me.
Same.
So.
Yep, I bought one too. They're really cheap. Though. It's really good.
So where'd you get
$27
it from? At Microsoft?
Amazon.
Amazon.
$27. It's called
Waveshare.
Waveshare. I can put the URL up on the copy on the deal.
It's called the General Robot Driver.
Yeah,
They also have a ROS driver, which is slightly different configuration, and it ships with some of their ROS robots, but they don't sell it directly over the store.
There's the URL. I posted it. So
Cool.
yeah, it's what I liked about it was it's all in one card, and I haven't messed with a ESP32. I'm still in the Arduino world, so I'm fixing to venture out. So
Yeah.
it'll be fun just learning this stuff. So that's all I got.
I started an Arduino too, Michael, and I got pulled into the ESP side, and now I'm stuck. I can't go back to Arduino.
Well, you don't want to relearn everything, So
But just the ESPs can do that and so much more. It's like, oh, so good.
well, I'm fixing to give it a try.
Cool.
And it's and I like to mess with the MicroPython and see what it's like too. So
Yep.
I've been trying to do that for years, but I haven't.
That's time.
That's time before I go to heaven.
Yeah.
I need to hurry up. That's all I got, Pat.
Okay. Thanks, Michael.
Yeah.
I have a question to ask the group. Not sure if anyone has any information about it, but I've been looking for a way to run a Raspberry Pi Pico or RP2040 in I2C slave mode. And I've come up with a couple solutions where people have created their own, but it's not ideal. Ideally, you'd want to have it enter like sort of an interrupt service routine when it gets queried and be able to automatically parse a response instead of polling to see if you have data, as a true I2C slave would be doing. So I'm not having much luck. I've been trying to use a little RP2040 Zio board for an encoder. Encoder on my CAN robot, and I sort of hit a stumbling block with this. So I'm thinking about switching out to an ESP32 Zio and just running interrupts for the encoder and using the I2C slave mode out of there.
Pat, what language are you operating in? Are you programming in?
I'm looking at either MicroPython or C++ Arduino.
There are a number of libraries to do that in the Arduino domain, which of course would make them C++. They are interrupt driven. They perform through interrupt response routines, and I think you'll find they're quite satisfactory. I've used them once already.
Okay, and that's on the RP, like on the Pico or the RP2040?
Well, if you take a look at the Arduino-based libraries, you can use the Arduino development environment to program all of those machines, whichever one you want to play with.
Okay, I'll take a look at and see what I can find.
And even if you don't, you may find, even if you want to use something else, then you may find the libraries themselves will be reusable. You're using VS Code?
I mean, for this one, because VS Code was a little bit more trouble to get the PIO info into the RP2040.
Right.
I use the Arduino IDE, which does it no problem.
Okay.
And so it's the encoders are captured in the PIO.
Yes.
And then I use the I2C to service interrupts. to service calls, basically.
Okay, sure.
So if I send, if I query that I send out a command of 1, it's okay. Well, clear the encoder values. If I send a 2, hey, it's a read back the encoder values for left and right, that
Yeah.
sort of stuff.
But I think you'll find getting a slave I2C running that is interrupt driven. That is, when you receive a request from the master to do something, you'll get an interrupt, and then you service the interrupt to reply to it.
Okay, well, so far I've been trying with the Arduino IDE, and I haven't had it respond to my very simple test is to use I2C tools on my Raspberry Pi to try to see if I can even see it on the I2C bus.
Okay.
And I'm not seeing it.
Okay.
Now, when you say you're using Arduino, are you using the thing called Arduino Embed Core? What sort of core are you using, or what?
No, I don't believe so. And hang on, I'll connect to my other machine, and I'll verify what I'm using. So I am using, it's Arduino, and
I'm asking because I just did some searching, and that specifically was referenced as supporting it. So I don't know if it depends on what kind of Arduino environment you're using. Maybe it's not universally supported.
yeah, so
The hardware supports it, right? So it's there. So it should be largely a software problem.
Yeah, I would agree. That sounds right.
So I'm using it's a Seed IO RP2040 is the board. And how can I tell what platform I'm using for, if it's embed or? So it's using Pico SDK. I'm just looking to see what else I can find here. And I thought the Pico SDK did support I2C.
Well, that's what my quick research here is also showing, which probably you've done already. But it's what I'm finding here. It has to be greater or equal to version 1.5 of that SDK.
Yeah, and I don't have that displayed here. So there is an Arduino Embed OS available, but it's for nano boards. I don't have it installed. There is an Arduino Embed OS for RP2040s that I don't have installed. I thought they were moving away from Embed. I thought Embed was shutting down. But I could try that. I could install Embed, the Arduino Embed library board manager, and use that.
Yeah, I mean, it just sounds like a bit more Googling might be needed here, but to get just the right combination of software that supports it.
Yeah. And that's what I found. So I've tried just a basic giving it an address of 5 in this case, and saying, okay, well, if I receive anything request, then go to some sort of response. And at this point, I'm not.
And it has to be Arduino. I mean, so what I'm reading is MicroPython. Oh, sorry, CircuitPython supports the slave. MicroPython does not yet support it, for example.
So it can be, because I can do PIO in CircuitPython as well. So I can flash it to CircuitPython. It's just, I thought it would be, okay, it's MicroPython or CircuitPython. It's super easy. Just there'll be a dozen examples out there, or hundreds of examples. And so far, all I hear is people having trouble trying to run it in slave mode. Which you'd think that something in a little microcontroller would be, its natural ability would be to run in slave mode.
Yeah, I think it's just because, most of the environments, they're focused probably more on master mode because it's the more common use case, right? You talk to some sensor, and maybe the slave mode is more neglected, not properly tested.
Yeah. So maybe I'll take a look at CircuitPython. It's something that I thought would have been super easy to just get this going. I thought the PIO portion would be the hardest part to get it integrated, and that seems to integrate fine. It's just to get the slave mode working. So I will give that a try again and see if I can get this working.
Well, why does it have to be I2C? So let's suppose
it doesn't. I could go to serial. So serial I know would work.
Yeah. I2C is just always a pain in the butt, I find. I mean, except in certain simple cases, but
yeah, well, that was my other backup plan.
Based on how much time you've already put into it, I would always say,
Yeah, well, something that
change
should have been
course.
super easy, read a set of encoders into a Raspberry Pi, and it's been driving me nuts.
Go for UART.
That's what I might do, is just run a USB cable and just say, okay, it's UART it is.
You already have used up all the built-in UARTs of the Pi?
No. My Pi has two USB ports being used, one for a stereo camera.
No, I mean the actual UARTs, right? Because since you mentioned you're going to add a USB to UART, I'm asking, what about the built-in UARTs on the Pi?
No, I haven't used the built-in UART.
Well, go for that. No need to add a USB widget.
Well, the USB's connector is already on the board. The little Zio comes with a USB, so all I need is a little 6-inch USB cable, and I'm live.
Okay.
Otherwise, I got to take everything apart to get to the
to
the board.
And your Pico. So your Pico already has a USB device interface, also.
Yeah, it's a Seed Zio RP2040.
Okay.
It has a USB-C on it.
Okay. Yeah, so you're right. Actually, then just USB to that from here to there might actually be the easiest. Yeah.
Yeah, and that'll give you
I mentioned it before on the call because I've done that from a Pi to a Qt Pi board, which is the same form factor, right? Just has a different micro on it. I forgot what it has on it, but it's this tiny little squarish kind of board, right?
Yeah.
Also with the USB-C on it. On my bot, a standard cable, I found it to be too bulky. So I made a custom USB cable for that use case, just real simple. Just so I don't have like 3 feet of cables that are spooled up somewhere. Or even if you make it shorter, or cut it yourself, I guess you can take some of the bulk out. But I guess my point is, if you're low on space, or you're just sort of gonna end up cluttering up everything with a USB wire, just make a custom wire. You can get just the USB-C connector also by itself.
Yep.
Right, and the USB-A. So it's actually straightforward to make a custom low profile, short wire if you have to.
I have a neuron firing, as fuzzy as it may be. Just said that something tell me that, like with Ethernet cables, there's a minimum length you can have an Ethernet cable between the connectors because reflection and the signal to actually get good thing. Is there such a thing with the USB world?
I don't think so.
I have 6-inch USB cables that I use routinely on the robots.
Yeah.
Okay.
I've gone at work at a design a couple years ago. We've done at the board level, PCB level, we've gone micro to micro USB signaling at circuit board traces. So really short, but that was the most natural way to get two micros to talk to each other.
I got you. I didn't know. It's like I was really curious because I'm like,
okay. I also use 6-inch Ethernet cables for work. So when you connect to
those aren't supposed to work, but from what I remember, but if they're working, they're working.
Yeah, we use 6-inch cables to go from drive to drive on applications, variable frequency drives that are stacked side by side. And the drives that we're using, the servo drives, are only 2.5 inches wide. So we just jumper the ports, and that's as of the manufacturer specification. And they work. They seem to work well.
A lot smarter people than myself have figured that out, so I'm going to trust them.
But in that application, is it actually Ethernet or just Ethernet cabling and the connectors?
In that application, it's actually Ethernet communication because it's Ethernet IP.
What?
From a large manufacturer, and they're using what they call SIP sync, which is time synchronization for, this application, it's motion control. So where I'm syncing 4 drives together to do servo motors on a linear track.
Okay.
Like an inverted scissor lift. And so I pick up a sheet of veneer and I load it into the feeder. And that works well just by Ethernet. This is, like I say, I've used the short USB cables. I would say without any issue on several robots. Typically I'll watch Amazon, and if I can find 3 or the whatever for a decent price, $10 or something, I'll order micro USB, mini USB-C. I have several different varieties and 90-degree connectors, whatever, because they're handy. But that's it. If I can't get this I2C working, well, then I think I'll follow your advice and just drop to serial.
Because what's nice about serial is, right, now you can connect it more easily to other things like your desktop PC or laptop, right? You can run something on there, talk to the other thing on the other side over the UART. It's just always more painful when you're dealing with SPI or with I2C. Those interfaces are just so much more specialized that it can sometimes just add a little bit of pain.
So yeah, well that's exactly it. So I'll see how it goes. I'll give this a little bit longer, and then after that it's time to switch out. That's it for me. I don't know if anyone else has something to bring up.
Yeah, Mike had something. So I was chatting to him in the text, but he says he has an issue.
Hello.
Hey.
Hey, Mike.
Hi. Yeah. Well, I have a OpenMV camera for blob detection that I was using last year. and it seems like it like it's not centered anymore. Like the object that you're looking at is offset. Yeah, I'll show you my OpenMV IDE. Yeah, so I have the green laser. You can see it pointing, and I'm pretty sure it's straight, but the can is offset a little bit from the center of the field of view, and the camera seems to be pointing straight.
That's not open.
So, I mean, I know I could just shift it in software, and say move the center point of the y-axis here, the x, y, what do you want to call it, to line up with where it really is. But it seems like a mechanical thing changed, and I know that the camera can have have the sensor removable, so you can upgrade it to a different sensor type. Maybe it shifted, maybe it's a little loose and it moved a little bit.
Mike, is your camera mounted on a servo?
No. It's hard mounted, pointing straight. I mean, if I want to look around, I'll just rotate the robot.
Did you update the firmware on your camera?
No, I haven't. It wants me to do it, but I haven't done it yet. It keeps bugging me every time I log in. It says, "Oh, your camera is out of date. You want to?" But I say, "Not yet. No." It works pretty good, but you can see that the green line here, the laser, that's keeping the can from being detected, because that green line sort of keeps it from being a solid. Let me turn off the laser here. Yeah. So that green line keeps the can from being detected, because it breaks it up into two orange blobs, and then they're not the right shape anymore. So
What do you?
So I was wondering if anybody had any,
What are you using the laser for? Just to help you line it up?
Yeah, just for me to line. Yeah, just so I can know when I'm pointing straight. It's usually for like the quick time and the four corner and stuff. You don't have to really point it that straight for 6CAN, because it's going to figure its own thing out. So today I enabled the software to do CAN detection and put a point into ROS that says, "Hey, the can's at this location," and I had it drive to the CAN. So it'll drive to it even though it's off, but it's just not right.
Maybe I don't know, but maybe once you use your laser, it can kind of automatically shut the laser off.
Oh, well, during
And
6CAN, I would turn it off, and that's
Oh.
because that's not the issue. The issue is it's offset from the center. And last year it was pretty much lined up with the center line of my my field of view.
I got to ask the obvious. Are you sure your green laser's actually straight like you think it is?
I think so. I think it's, I mean, I've run a string.
I think you need to turn that think into yes. Not a think, not a could be, not a should be. I think that needs to be a yes.
Well, I think it's off by a centimeter or so. This is like 50 or 60 or 70 centimeters off.
I mean, I'm a big fan. If you think something's known good, every time you check it, it should always be good.
Oh, yeah.
So
Yeah.
you don't have to worry about it.
Right. Because I take a straight, some piece of straight material, like a line or a stick or something, and put it in the center of the robot, line it up with the camera lens going straight out, and it's pointing straight at the can. So I've done like a physical thing, like, okay, well, what is straight? So that's I'm gonna try to stop sharing this. So that's my stump the chumps.
Saying all that was a cool looking interface, man. It's a cool looking interface.
Yeah. So I'm wondering if I take it apart and go look at the sensor, maybe it's not flush. Maybe it twisted a little bit because it's. I'm not sure how it attaches, but you would think it'd be pretty strong. But something shifted. Something shifted. And I'm really sure that the can is really close to being straight ahead. I've checked it multiple times in different ways, and the laser is pretty good. It's pretty much straight. Yeah, like I said, I think it's off. When it's a meter away, it might be a centimeter off or something, but it's good enough. So I just didn't know if anybody had any experience with these cameras.
No microscopic black holes or anything that make the light bend, and I'm trying to be funny.
I got one for you, Mike. Did the robot fall or get dropped at some point?
There was a bang once. Yeah.
So was it possible that the camera got knocked off of slightly off of center and at a distance of whatever that can is, 6 feet and it's out by a few inches or a few centimeters.
The camera module itself is really tight and it didn't move, but I was wondering if some internal component inside the camera could have moved. Yeah, because
I'm not. Which version of the OpenMV board do you have?
The 1062. It's the new. I don't know if it's newest now, but it was newest last year.
So that one there, is it possible? Does it have a separate lens that screws over? Is it possible that lens came loose, the lens housing?
Yeah, they're going to ask somewhat the same thing. If some of these lenses will autofocus, and they have and that autofocus is mechanical.
This is manually focused, and I put the lens and see if it was loose or anything, and it was still tight. It didn't churn. It didn't change. Like the focus was still in.
That board, I believe they can change the CCD or not CCD, whatever they're using for the camera on it. Is it not swappable?
Yeah, you can put different sensors in it, like a ultraviolet or infrared. I think it's infrared, and you can put like instead of a scanning sensor, it can be a one-shot sensor. I can't remember what those are called, but
global shutter.
Global shutter. So you can change the sensor out.
So is it possible that board is not screwed in all the way tight to this, so it's parallel to the PC board?
Possible. I would have to take the camera apart, but it's doable. So I might do that. I might open it up.
The one board plugs in and sits onto the board, but I believe there is a couple captive screws to hold that board in place.
Yeah, I would hope so. I would hope it would hold it tight, but maybe I haven't looked inside the camera yet. I was just that was my thing. It's like, okay, if something shifted, it might have been inside, or the lens somehow shifted without the yeah. So
which version do you have, Mike, of the OpenMV? Which one do you have?
1062. RT 1062. So it has the same global shutter and the same lens system. It's just a different CPU than the earlier versions. I mean, I think the lens system changed a little bit over the years. This is a little different than 2 or so versions back, but so yeah. So I hate to take it apart and make it worse. that's the big fear, is like taking it apart and making it worse. But
yeah.
but you should be able to disassemble it and put it back together and make it. And yeah, it's designed for that. So it's not like I have to break seals or anything to get into it.
Mm-hmm.
Is it inside a case?
Pardon?
Is the OpenMV inside a case?
What do you mean?
Like, is there a plastic case around the OpenMV camera?
No.
Well, it should be. Usually, it's just a couple screws to pop that circuit board off or to check they're screwed in.
Oh yeah. It's a couple screws. Yeah.
Yeah, it's not nothing super serious, I don't think.
Yeah. So
you don't need a hammer.
Yeah. So
You
so
always need
there's-
a hammer. You
Yeah,
always
so
need a hammer.
so you can see it right there. And
So a
you
couple
can see
screws
like
from the
from the
back,
top.
the lens housing, and
So it's
Yeah.
solidly attached.
Hmm.
Yeah. It's it's a real solid mount. It's just yeah. But I think what you're so I don't know if you can see it, but it's these two screws there.
It's slightly off camera. There we go. Yeah.
yeah. So I'd take a look at that. Yeah, and then is the camera still sitting square to the robot? That's the other question. You have it mounted on something. I don't know if that's a LiDAR or what it is.
Well, it's mounted on a really solid platform that the LiDAR is mounted onto,
Okay.
and yeah, because I look at it and it's like still lined up perfectly flush with the LiDAR, so it's a really solid mount here. Yeah, it's a lot of 3D plastic. Yeah. So it's like, okay, figure out what that angle is and subtract it mathematically and get on with life.
Yeah.
But if I can fix it mechanically, I should. So that was my thing.
They have a really good 3D model on their website I'm looking at.
Yeah, can you pop it up?
Sure. I say that. Take that one over there. Like Karim, I got too many windows open. Which one was it? OpenMV. Sure. Yeah, there you go.
Mhm.
But yeah, so it looks like there's like maybe a couple screws. I mean, there's obviously screws attaching it to the PCB, but then it looks like there's a couple more once you've removed it from the PCB that could pull the back off. Maybe.
Yeah, because that lens assembly will come off, and then
Yeah. This is a great model.
yeah, that's what it looks like.
Say cheese. Yep.
It's pretty straightforward. Just a couple screws that hold that camera module to the board, and it would be pretty easy to see if there was a gap on one side to shift the camera slightly over.
Yeah, if that. Yeah.
Yep.
Yeah, so I guess I'm gonna start messing with it. It's like I didn't want to have to mess with it, but
What?
like I don't think I can make it worse. So
Oh yeah.
That was a famous last
Wait a
word.
minute. There's an age old saying, there ain't nothing so bad that can't get worse. It's all there is to it.
Yeah. Oh man, tell that to Robbie. Robbie's a skeleton right now.
Oh, he's in the skeleton closet.
No, he is a skeleton. He has took his body panels off and took his neck out. I think I fixed his neck, by the way, Mike. I think what it was, we thought it was that well, I thought it was that bearing in the neck.
Yeah.
Well, the PVC pipe is just pushed onto that wooden block, and as soon as I started pulling the PVC pipe away, it created a gap. So I think the PVC was creating friction on the neck.
Oh.
So as soon as I pulled it, it made a gap. It was better, but yeah.
Huh. So the when the head rotated, the PVC pipe rotated, and it was
rubbing on it. It was rubbing on the neck plate. Yeah.
Oh. Okay.
Yep. So I need to get back down there and fix it.
Make it better, not worse.
Make it better. Yeah. I want to try that elbow as well that Ron brought in. So I think I need to 3D print a couple more parts for that to make it fixable. But yeah, should be good.
Yeah, because it's pretty easy to control. I mean, with Arduino libraries to get the feedback and the encoder feedback and the motor control.
Yeah.
And it doesn't take a lot of power. It just needs like a 1 amp driver, 2 amp driver. So.
Yeah. I was thinking of putting it in the static shoulder one arm first, the left arm. That seems to make sense to me, but
yeah, I on my robot, it seems to be the same motors as these.
Yeah.
And so we let's see, where is that? Oh, so we unplugged one of the cables on this board. Which one was it? It was
there's the one there's the outside, which I think was your right wheel.
Yeah, that 6-pin one with the right here.
Yep.
Yeah. So we unplugged that one and plugged the motor in from the elbow in there, and I gave it some commands to rotate, to run, and we were able to move it. So.
Yep. It's a good test. Maybe we need another workshop to work on that. Oops, sorry, my dog's playing. Rubber chickens. Cool.
Yeah. So do you need me to make some code, make a little board with a connector on it, or?
Sure.
How would we interface it?
Well, right now we do have a spare motor driver on the board, but only one.
Oh, okay.
So
that might be the easiest way to do it. Yeah.
Because
I was thinking if you put a microcontroller in the elbow, then you got to send a command to the microcontroller somehow. Yeah. But if we use the motor, if we can use the spare motor driver, it's even better because Arduino can control it directly.
Yeah, that would be better.
And just 2 wires, 2 simple motor wires.
Yep.
Oh, but the encoder has to come back. I guess you don't really need you really want the encoder. Or do you?
Well,
it's just
the motor.
I don't think it has positional information. It's just delta information. So we need to get that fault sensor so that we know an absolute position on it.
Yep. Another workshop in our future.
Yeah, but I think the quadrature encoder, we could probably live without it because we're not trying to precisely move it at a certain rate of change. Yeah.
Yep. Very cool. You got anything, Paul? Muted. There's that mute button. Is that somewhere?
I had a demo working, but it's not quite working right anymore.
Well, the artist that I put the little spinner for his art, he says that it sort of wobbles a little. And I think my 3D printed attachments, it's like some cross members, bars that are about that long. I think they're flexing. So I need to go reprint them with some ribs in them to keep them from flexing, because it's like wobbling. You know, it wobbles on the, if you push it on the wall, it sort of wobbles, and then since it's hanging out from the wall a certain distance, it has a downward vector, gravity, and that's causing it to have a little bend to it. And so every time it runs around, it just
flexes.
I'm worried that the plastic will fatigue.
Yeah. Are they just rectangular struts?
Yeah. And it's also pretty cheap when it's wobbly. So, like, it doesn't look wobbly when you look at it, but when you touch it, it wobbles. So, I need. I don't have my mechanical degree, engineering degree.
Well, if you want to bring it up to the Makespace, we can have a look at it.
Yeah. So I just have to make that ribbing stronger. So, because it's just like a 3 millimeter plate, 3 millimeter long plate, and so it has a lot of wiggle to it, flex to it. So that's easy to do. Just take the design and add some ribs to it and reprint it.
Which filament are you using for that?
Just ABS. I mean, and not ABS, a PLA. So PLA is pretty rigid, but
I wonder if PETG would be more.
But it will fatigue. Yeah.
Yeah. Yep. Well, I got some PETG if you want to try PETG.
Yeah, that has more flex to it, doesn't it?
Oh, sure.
Yeah. Like, I know ABS is nice and strong, and you can move it without breaking it. PLA has a lot of tension. Like, it moves, but it'll break.
No, you're right. Yeah, PETG has more flex.
It's not really designed for flexing, the PLA, because it's more rigid than the other common ones. I'm sure there's better ones, but that's all my printer can do, PETG. But I was doing that when I need something special or need something more flexible.
So I guess I do have something to show. It looks like it's working. My servo, I got a dodgy connection, kind of like, Robbie, need some of your ministrations, Mark or Mike, whoever. Mike, you fixed Robbie's servos. I need some of your ministrations. But whoops, if you pin me, and I will share this window, and so let's see, are you seeing? Yeah, there we go. So you're seeing Aviz and Minibot looking at a can, and you can see from Aviz the can is just off a bit to the right of Minibot, and so I'm going to fire up. So I guess to set expectations, what I got going, I finished writing up the specs for the state machine that would do a capture can sequence. So that's assuming it's been deposited, assuming it's been in the vicinity of a can, then capture can is a module that will rotate to point at the can, then go and grab it, and then take it back home, and then drop it and back up from where it dropped it and turn around. And so that's what I'm about to show. And the whole thing was generated by Aider, except that I had to fix like one or two minor things that Aider did wrong. But here we go. So hopefully. Waiting for nav2 to be active. Okay. Now it's rotating a little bit to point at the can more directly. Now it's going off to grab it. Nav closes the jaws and then backs up and returns to the goal, goes off to the goal position. Releases the can, backs up from it, and then rotates 180 degrees to point away from the goal so that it's ready to go and fetch the next one.
So, so some of the code you have is using the navigator. That's to go
Yes,
close to the can, and then you switch to your custom code, right?
correct.
Is going to the goal using navigator, or is it custom?
Going to the goal is using navigator.
Okay.
I started, so the overall the bit that I haven't done yet is going to different places in the arena to look and see if there are cans there. But so this demo starts where that would lead off, where that would leave off. So the assumption is it's been placed somewhere in the vicinity of a goal, and so you can do that again and place that over there maybe.
Yeah.
And so it's been left by the navigator somewhere in the vicinity of a can, and and so then the state machine. I was like really impressed. Ada made a real state machine. I just told it I wanted one, and off it went and created one, and it worked with all the states that I specified. So it rotates. That's one state, and then it uses my code to drive up to the can and grab it. Now it's back on navigator, so I'm handing off between navigator and my code, and navigator is tracking the whole while. And here it comes. You can see the little dotted lines on Avi's of its path to the goal. And it opens. Then that's my code that's backing up because it's too close. It would be in collision. Another thing I forgot to point it out, but what is working really well, and Chris, you probably expect this, but I didn't know if it would work or not. When it's got a can in its jaws, and I want to use the navigator to drive back to the goal and avoid other cans on its way back to the goal, but it's got this can that's an obstacle in the LiDAR, so it wouldn't drive anywhere. So what I do is I blank out the forward 45 degrees of the LiDAR, and so it's doing its localization. It's running the AMCL localization on the remaining 315 degrees of LiDAR, and the things that that's seeing. So I was quite pleased to find that would actually work.
Yeah, I think that makes a lot of sense. Just simple approach, right? Just throw out the data that's going to confuse the algorithm.
Yeah. Yeah. I just didn't know if it could drive forwards with the missing 45 degrees of view, but it does it just fine. Of course, it can't see any obstacles either. So, if there was a can directly in its path, it would just barge it aside, I guess. Anyway, so that's my demo.
Well, today I detected a can with that camera, and then I dropped a transform, like I said, this is my can location, giving it a a transform, a TF2.
Yeah.
And then I basically did the math, the calculation says, okay, go to that can, but I had it stop right before the blue area.
Oh, before the collision detection would take over.
Right, because if you try to say go to the middle of the collision detection, the obstacle area,
Right.
it'll give all kinds of weird paths to it.
Mm-hmm.
But if you say go straight to the edge of it, it does a really good job of just going straight to the edge. And then you can then I'm planning to do what you're doing is switch over to some custom code to go and line up precisely and go grab the can.
Yeah. Yeah. So it's pretty cool stuff, really.
Mm-hmm.
Hey, Paul, how does it know where the how does it know where the home is or the dot on the floor? Did you program that in ticks? When you take the can to the goal, how did it know where the goal was?
That's a really good question, Mike and Michael. And so it knows where it is because it's got this map that you can see, kind of like there's a kind of a teal outline. Let me turn a couple of layers off here. Okay, so you see this kind of like an upside down U, sort of like a lopsided upside down U. That's
right.
That's a map that I gave it, that I drew in Inkscape, and at a resolution of 5 centimeters per pixel, and those are the walls, and then the white dotted line that's sort of wiggling around is the LiDAR hitting the walls, and so it's matching that up. So it knows where it is by aligning the LiDAR scan to the walls in the map, and then the goal location is just a coordinate on the map. So as it drives around, it tracks where it is in the map based on on aligning the LiDAR to those walls in the map. Does that make sense?
Yeah, absolutely. Did you like just kind of click in that area there and tell it to that's
no
like
no I there's a API to the navigator that I use, and you can tell it to go to a certain pose, and so I figured out what the location on the map is. It's about 0.3 in X and 0.7 in Y, because 0, 0 is down at the bottom left here where this green and red axes is, and so I just tell it to go to 0.3, 0.7 with a pose of minus 90 degrees, which is pointing south, if you will. And then, so it does that. And then I open the jaws and back away from it 15 centimeters and then tell it to rotate. It's a kind of a mix. It's a mix of some of it's being done by my navigation code that knows how to rotate in place and how to seek to a can using the LiDAR bearing and how to drive straight. And some of it's being done by the ROS navigator, which knows how to drive in a map to a coordinate with a goal pose and avoid obstacles on the way.
Did you create a transform, a TF for the goal?
I did not. It's expressed in the map frame, and so when you use the basic navigator, you give it the goal pose is in the map frame.
Okay. Yeah, because I was dropping a transform and just using the transform math for the to say go here. Yeah.
Oh, I don't know why you have to do a transform, Mike, because like basic navigator goes to a pose in the map frame.
Right. Right. Yeah, I guess I was just doing it to have that little cross on the map.
Oh, for where the can is.
Where you want to drop the can? Yeah.
Oh, yeah. Well, so I did do a transform for that. Yeah. So
can you turn it on?
Yeah. Yeah. So it's on. I'm still sharing the Aviz window, right?
Yes.
Yes.
So you can see I'm zooming in on the can here, and this is a little axis here.
Yeah. So that's the dynamic transform for each can. Yeah.
Yeah. Right.
I was thinking for the area you want to drop the can off. Did you create a transform for it?
Yeah. So I don't need to do that, but I did create a transform for where the can is, where the center of the can is, and so that I could put this axis here, because that's sensed in the LiDAR frame, which is, the LiDAR frame is derived from the base link frame.
Okay, well, yeah, I guess I just did something extra. I created a transform to say, go to this particular spot, and then I have a go to pose, which I send it the transform. Use this, and it'll go from the map. It'll compute the pose from the map to that spot. But yeah. Otherwise, just hard code some coordinates. It works good too. Instead of getting hard coded coordinates, creating a transform, and then undoing it all.
Right.
Yeah.
Yeah. So anyway, I was pretty pleased.
I noticed your other two cans are getting those little transforms too.
Which?
The little two cans in the upper right-hand corner.
Yes. That they're flickering in and out because they're sort of at the limit of detection. But I guess if I hide this one, it might actually go and get one of them. I don't know. We can see if it will actually find one.
Yeah, if it gets closer, they'll be more steady, right?
Yeah.
So it's turning that direction.
Here we go. Off it goes.
Because those are off in the shadows of your
It sounds like a rat trap when the jaws go.
Wow, it backs up a long way.
Yeah, it doesn't mind backing a long way. It seems to be perfectly happy doing that.
Yeah, Navigator hates doing it, but yeah.
I think you can tune that with the navigation parameters tunables, but okay. Then it released it, backs up, and then rotates 180 degrees.
Awesome.
It's getting close.
Yeah.
And that's it. It's done. Anyway, fun stuff. Cool tech. Okay. Actually, I won't stop. I've got actually a couple of things that I thought y'all might be interested in. So we had a fun exhibit day at the Makerspace on Saturday. I'll just share a couple of photos from that. let's see. Share. This one. Let's see. Is that sharing?
We just see your torso.
Can't share my screen. Something went wrong. Okay. Try once more. Okay. There we go. Yeah, so unfortunately so there's a picture of Robbie at the exhibit, and Scott's number 9 robot is there in the 6-can arena. That is an impressive robot. That is the one to beat. It was doing well. It not perfectly, but well. And it was really fun to see everybody had brought their robots, and we had quite a few visitors from the makerspace and not sure where else. This was cool. This was
Yeah, they had a lot of what is it? Tours. A lot of people showed up for a tour on Saturday, more than I've ever seen, actually. That don't mean it's more than I've ever had, but there were a bunch.
Is this a Pololu? What do you call it?
I don't know what it is. Anyway, it does remarkably well.
Mm-hmm.
So anyway,
It seems like a sumo robot could be easily adapted to do this.
it does, doesn't it?
I tried my Zumo on it, and it did okay.
Good.
It couldn't do the staggered lines very well, but
Hmm.
it did the rest of it pretty good as me.
There's just a few more of us
Working
Anyway.
away.
That was from the exhibit.
It was a really good day.
Yeah, it really was. And, thank you to everyone that came out. And,
Yeah. Well, I think Paul and I figured out why our robots weren't working good that day.
yeah,
Like we were using the same ROS ID, and so we were colliding in the ether.
yes.
As soon as I gave up and shut my robot down, then Paul started working. He's like, "Wow, it works." But we didn't realize that until later, much later, after the event. So I gave mine an ID of 18. So
Thank you, Mike. Sorry about that.
no,
Ruining your testing.
I just never had that problem by myself.
And then the other thing I wanted to mention was this Friday, 8 o'clock, is Rossum's Universal Robots, community theater. So I'm not I know Mark's going, not sure if anyone else here is going. I'm sorry we had to change the day on you, Mike. But it's the play that originated the word robot. And anyway, that should be fun.
Oh, good.
Yeah. Are you still going Saturday, Mike?
Wear your robot shirt.
Yeah. Are you going to go on Saturday?
DPRG robot shirt. Yeah.
Hey, Paul.
Yeah.
I remember I showed you. I don't know if you remember, but Saturday I showed you my what do they call it, quick trip demo.
Yeah.
And I turned my robot around, and you kind of said, well, you said, a lot of people don't know. They need to give you extra points for that.
Yeah.
And I don't know. I thought about it. So when I got home, I reprogrammed my robot not to do that. So it actually working better where it's just going up there and back. So
Yeah, well,
I do believe did they amend the rules from last year to this year that if you do the turnaround 180 degree, you get bonus points?
no,
okay.
no, that's not in the. I don't believe that is in the rules.
We talked a lot
I
about
thought
it.
that, Doug was going to change that in the
Yeah.
rules that you got an extra point for turning around.
Yeah.
No, okay, I might be wrong. I'll check it right now.
Yeah,
but-
go check it. Go check it out.
But-
There was a bunch of discussion about that, and
yeah.
Well, then I'm good to go either way then.
yeah, you are.
Mhm.
I tried to persuade Doug to do that, and he wasn't having anything of it. But I really think it deserves extra credit to turn around at the far end.
I agree, but
Absolutely. Yeah.
So let's next time Doug's on, maybe we can talk to him about the rules. No, I'm looking at the rules, and it is not
It's not there. At
not
the
in the rules that there's any extra point for turning around at the far end. It just says,
Well, in general, turning around will cost you a little time. So
right. And his reasoning was, and I to a certain extent I get his reasoning. His reasoning was keep it simple, make it something easy for beginners to do. But I still think that there's merit in doing it better. So let's have a chat about that next time with Doug next time he's on.
Mm-hmm.
if you spin 4 times, you get 4 extra points.
In like a washing machine.
Flip it over and go back.
where's the
now I guess
Carl
we're calling.
robot that does the pirouettes?
Then
I like that because it is harder to spin more times.
then not only do you get more points for spinning more times, but we'll have to measure your angular velocity. So if you spin really, really fast 4 times, you get more than spinning really, really slow. Oh, it never ends, right? It never ends. You gotta draw the line somewhere.
Yeah.
Yep. So Michael, you're in better shape now that you're just going out and backwards.
And I have that other option. I'll just load that other code in there and
Yeah.
see.
But the current rules do not award that extra point for turning around, and I think that'd be a differentiator.
Well, it does take time to turn around, so it would be worthwhile to try to get that extra point.
Exactly. And it's a little bit of a harder challenge. Maybe a lot, depending on where you're at on your growth curve.
Yeah, on your skill level.
Yeah.
Well, has anyone got anything else?
Nope.
Well, it started off as a slow night, but we did manage to get quite a few things in today.
We did.
Got a couple good robot demonstrations. 2 gold stars. Tom got 1. Paul got the other. It was a good night.
Very
All
good
right.
night.
Thank you for starting up the meeting, Pat. Appreciate it.
Mm-hmm.
No problem.
All right. Thank you, Pat.
All right. Good night, everyone.
Good night.
Bye.